at the actual process of packet switching and how it looks in a network sense. So when we have some data that we want to transmit across a network, what we have to do is split that data into equally sized packets. So let's say I've got a fairly large video file that I want to send across a network. What it's going to do is it's going to divide, let's say, that 10 megabyte video file into 10 1 megabyte segments of a video file. Each of those packets all have the same structure in that they are sent with this idea that you have a header, some form of data or payload, and then a footer. Now the header goes at the front of the packet, and that contains the control information, which includes the source, so where it's come from, and the destination and where it's going. So the source and the destination will generally be as an IP address, and if you're not sure what an IP address is, make sure you have a look at the appropriate video on that a little later on. And then also it will also send the MAC address, and again there'll be a corresponding video for that later. It will also send the packet number. Now imagine this is like the outside of an envelope, if you like. So on the outside of like an envelope you were sending it, on the front you would put the address of where you want it to go to. On the back you would say, if it doesn't get sent, here is where it's come from. Now the packet number itself is about order and sequencing, which I will explain on the next page. Now the next part of the data packet is the data or payload, which is the data itself, and this is the contents of the envelope, so the letter or the thing inside the actual envelope. And then the footer contains something called a checksum, which we will do a separate video on, which you can have a look at. And this is a kind of validation to ensure that the data has been sent or has arrived correctly. And to kind of summarize it briefly now, it's a mathematical equation that's then that is sent through, and it's a mathematical equation that both the sender and the receiver know, and it's when a series of numbers are added together, multiplied, divided, etc., if the same answer is arrived at, then it knows that the data that's been sent and the data that's been received is accurate, and that it's a reliable piece of data. Because when we transmit data over a network, what we don't want to have is interference that changes a packet of data. So if I enter the letter A on a keyboard and I'm sending that to a computer somewhere else and the letter Z appears, it's going to mean two completely different things. So if we take a look at an example here, which looks maybe slightly more complicated at the start than what we've got, computer A is wanting to transmit 3 packets of data to computer B, and these values labelled R are routers. They may also be little nodes on a network, which may also act as a distribution as well, but most likely they are going to be routers. So there's multiple ways in which I can send a packet from computer A to computer B. I could go down and then across to the right, I could go across and then down, I could go diagonally, I could go all over the network. However, depending on how busy a network is at any one moment in time, it may well choose to go different routes for different packets, because millions of packets are being transmitted across the network at any moment in time. There are not necessarily going to be free moments on a particular part of a network at any instance of any moment in time at all. So we can see here that packet number 1, because that's what it's been labelled in its order of sequence, has gone all the way across the 3 top routers, then it's gone diagonally left, diagonally right, and then it's arrived at computer B. Packet 2 has gone initially into the first router, then down to the very bottom router, and then all the way across to the end, and then packet 3 has gone entirely diagonally across. Now when they've arrived, we can see that, well, packet 3 has arrived first, then packet 1 has arrived, and then packet 2 has arrived. What then happens is, because the packet sequence is put on the actual before it's transmitted, we can then reorder it into the correct statement. So if we think about that video file from earlier, we haven't got a video that's completely jumbled up, it's in the correct order. So it's an efficient way of using a network. It allows data to reach the destination regardless of heavy traffic. So I'm going to leave this slide up here, which kind of gives a bit of an overview of some of the more ins and outs of packet switching, but I think I've probably described everything that needs to be said about it, and anything in here will just kind of add to the extra layer of understanding that you may need for the exam.